My name is Meera,
And my name's Natasha.
and we will be walking you through the Raphael library. Raphael is a small JavaScript library that allows the user to draw vector graphics. It solves the problem of having to download multiple libraries to do different functionalities with these graphics. Raphael allows the user to draw graphics as well as animate them. Someone would not need to use this tool if they are not interested in making graphics themselves, and a library exclusively for animation would be a better solution. With the efficient and short code provided by Raphael, you are able to make standstill graphics come alive with little effort. The documentation is incredibly clear and intuitive, and we will be walking through some easy-level examples, as well as displaying some more complicated options that experts use Raphael for. It is similar to Firebase when you are manipulating a canvas and drawing with a paintbrush. Raphael is supported by multiple browsers such as Chrome, Firefox, Safari, Opera, and Internet Explorer. It is used for Apple's iCloud homepage, the Washington Post, and Time magazine's websites. The developer for Raphael is Dmitry Baranovsky and was initially released 7 years ago. To begin with, we'd like to show some real-world examples of how Raphael can create complex systems on web pages that display information in creative and visual ways. The animations support the graphics by giving life and meaning to the particular information being conveyed. This gives users the feeling that what they see and are interacting with truly represents its cause. Our first example is a visual clock with multiple hands representing different units of time through colors and sizes. This helps viewers understand the exact time and date. Another example is a maze game, where one tries to navigate a character through a maze, looking through the view as if it was their gun. You can see the complexity within this design and how it resembles many video game setups. In order to be able to use the Raphael library in your own code to follow along, you can download it from the site linked to our README file on GitHub. From there, you need to add the HTML and JS format to your files and connect them using script tags in the HTML to load the JS file. To start using Raphael, declare a new Raphael paper in the JavaScript file. From there, we can start experimenting with shapes and colors on a black canvas.
Okay, as you can see here, we've declared paper, and in order to create our circle and just get started with some basic objects, we're going to use that paper element. It's similar to canvas in Java, same concept. So you have a canvas displayed initially of 500 by 500, and the left corner here is at the coordinate 50-50. And here's our circle that we decided to draw with at the position 50-40 with a radius of 10. So you can see that circle, and we can assign certain attributes to this circle, such as a fill color. In this case, the fill color is red. And we can also decide to create some borders on the outside of that circle using what is called stroke, so it's the outline. You don't have to use hex colors like up here. We can also use just strings. So in this case, we have white here on this outside edge. Now that we kind of have an idea how to create very, very simple shapes, we can create something a little bit more complex. So what we're going to do is we're going to create like some of the foundational structures used in the game Tetris. So it should be lots of fun. So initially what we're going to do is we're going to create our Tetris piece. I'm going to comment out this circle here. We don't need that displaying anymore. So let's save and refresh our page. So we have our outline of our Tetris piece here. This is what we call a path. So a path begins with M, which means just it's a startup path. You don't actually start drawing any lines, but from there you can specify little translations in these lines so you can create and build shapes. So this L is drawing each of these individual lines here on our shape, and then to close this path eventually we just close it with the term Z. Now that we have our basic Tetris piece outline, we can do some fun stuff to it, and we can add some attributes. So if we save and refresh our page again, we have our basic Tetris piece that we're going to use. So we decided to use a gradient here, so it's a 90% gradient, and we went from like a darker blue to a lighter blue. And again, we added a stroke that has a navy edge, and you can also specify certain things about the stroke, such as the width. So in this case, we have a width of 10, and we also, like in the game Tetris, the corners aren't perfectly square, so we decided to round them a little bit with this line join. And we can also begin to do some interesting things that you can see for the foundation of Tetris, such as rotating the piece. So let's rotate it 90 degrees. So if we refresh our page, look at, we've shifted our piece. So you can kind of see the beginning forms of animation going on within the game. And we can also decide to animate this piece a little further and make it a little bit more interesting. Let me just expand my screen here for you so you can see that. You can track this. There we go. So let's comment out this past rotate that we did. And let's add some more interesting animation to it. So when we actually decide to animate this piece, we're going to have a little bit more of a bounce this time. So let's save. And refresh. Oops, it looks like that went amiss. Let's see here, what's going on? That just found some punctuation error there. Now we have everything up and going. So as you can see here, it's very similar to our rotate method, except what we're doing is adding a little bit more bounce to it. So we're animating this piece a little bit. So if we display this, you can see that there's a little bit more of a pop to what we're doing. Now if we comment that out, we can also decide to do things as well within this animation by calling this, so we're referring to this particular instance, and well, during our rotation we're going to actually make this outline purple, have a little bit more pop. So I forgot to save, I apologize, let's take a look at that again. Let's just refresh our page. There, now we have purple when we decide to animate. Okay, so now we have some basic ideas of how to structure the animation portion. We're going to write some of our own methods. So what we're going to do initially is we're going to figure out how to shift our Tetris object. What we're going to do initially is we're going to shift it to the left. So when you press your left arrow key, we're going to shift the whole piece over, kind of like what you would do in the actual game of Tetris. So what we're going to do initially is we're going to use a little jQuery here. So when our document, when you press a key, we are going to figure out whether or not to shift it to the right or the left. So we're going to do a callback function that takes in an event. In this case, the event is pressing down the key. Then from here, we're going to have a series of if statements. So if we press the particular left arrow key, so which key, we're going to refer to the left one, which has the key code of 37. We are going to shift our Tetris piece. So Tetris piece dot animate, and what we're going to do is we're going to actually use a particular feature that's called the transformation. So we're going to transform our piece, and in particular we just want to shift it, let's say 10 to the left. We don't want to deal with the y coordinate in this case, we just want to transform the x. So we're going to do for t for transform, and let's say we want to go to the left, so we want to go -10, very similar to a number line, and we don't want to change any in the y direction. So let's go with that. Then from here, we want to specify what sort of ease effect we want. So instead of the bounce like we had with earlier animation, we're actually going to do linear to make it more of a gradual. And let's say we want this over 2,000 milliseconds. So if we save and then refresh, we press the left arrow, oh good, we saw a shift. For those of you that missed it, I'm very sorry, but I will refresh it again. There we are. So you can see that it's the beginning of what you would do in the sort of functionality that you would see in an actual game. Okay, so we're just going to do a very similar thing for the right, or you can do a very similar thing for the right. I'll leave that up to you. The key code for the right is 39. So if you would like, you can go ahead and implement that as well. But for our last example, what we're going to do is we're actually going to add a spinning feature. So if we comment out our key down, let's add a spinning feature to create some really cool animating effects. So we have a var spin, and we actually want to call in a different thing than what we're used to. Unfortunately, element dot animation isn't actually an option. So what we're going to do is we're going to use Raphael. Raphael dot animation. And we're going to do a very similar thing. We're going to create another transformation. And what we're going to do is we want it to spin continuously for 360. So we're going to say R for rotate, and let's do 360, because we want it to spin in a circle, just like it does in the game. And let's say we want this over the course of 4 seconds, so 4,000 milliseconds, and we want this to repeat like indefinitely, so we're going to pass an infinity here. Okay, and now what we're going to have to do is we're actually going to have to call this feature here, so we're going to go Tetris piece, and then we're going to animate it by passing in our spin object, and let's say we want a linear animation just like we did before. And let's not forget to do a capital P. Keep everything consistent. Okay, so now if we refresh our page, we've implemented a spinning feature. So that's all we have for this demo. I hope you learned something about the basic Raphael library and framework. So thank you very much for listening. Meera is going to wrap things up.
Be sure to review all of our code and practice incorporating the Raphael library into your own projects from our repository on GitHub. Thank you for watching.